Well, welcome everyone to the XMTP Developer Community Call. Thank you everyone for being here. I'm Jeha, I work in Protocol Ops, and I'll be your host today. In addition to sharing the forum post where we'll post this recording, I just wanted to also share, I have a lot of sharing to do. I do a lot of sharing before we get into the meeting, but I believe that these artifacts are important to share as a community. So I'm going to put a link to the community code of conduct in the chat, and we share this and invoke it at the beginning of every dev call and all of the public gatherings of the XMTP community, and we do that to ensure that we start off creating a space where everyone feels welcome to share their ideas and ask questions. I would also like to start off this meeting by sharing a bit about the mission of XMTP, and we wanted to make it a practice of talking about this as a community a bit more and talking about why we gather as a developer community, not just in this meeting, but on Discord, in Discourse, virtually as a part of ETH Online, and so many other spaces where we nurture our community to ensure that the community is able to gather, able to learn together, and share to build XMTP as an open, private, and secure messaging network that endeavors to last forever. And we hope that this mission resonates with you and that you might feel alignment with it so that we can all work together to ensure that XMTP is accessible to everyone, that it is resilient and self-sustaining and decentralized. So as such, I thought we'd also like to share that today XMTP joined Metabased, a community of organizations that are committed to working together to develop and decentralize what so many of us spend our days working toward, a truly community-owned internet. And so with that, perhaps in a future meeting, we can have a discussion about the mission and go a bit deeper into that. But for today, I'd like us to head into the main event. Today, we have a topic that the team is really excited to share. And personally, I'm very excited about it because it explores some very cutting edge and novel explorations the XMTP core dev team has been doing over the last several months to address the rallying cry from the dev community when group chat web. And it's also exciting because it's at the intersection of some really powerful tools that are coming together to solve a problem. And so I'd like to hand it over to Andrew Plaza. He is an XMTP core dev at Ephemera, and hand it over to Andrew to take us on this deep dive. I'm going to stop sharing, and Andrew, will you let me know if you're able to share your
Sure.
screen? All right.
You guys able to see that?
Perfect. Yes, thank you.
Great. Okay. Hi. Yeah, I'm Andrew, core dev at Ephemera. Been working on the back end for our client stack with SQLite for the browser. And I was going to present about like how we came to our solution and yeah, all about it. So just pull my notes up here. Okay. Yeah, so I guess I'm going to start off talking about like what our stack looks like now. So we have a core library called libxmtp, and then we have a bunch of client SDKs that are bound to different to the clients through libraries like Unify and Nappy, which basically make the Rust code callable from iOS, Android, and Node.js. Once like control from iOS or Android is handed over to libxmtp, kind of going down the stack. We have a database. We use SQLite for our on-disk database for all our storage. We store things separately from OpenMLS, and we also have a trait interface that OpenMLS uses to store its stuff, whatever it needs to store. We also, anything for network is through gRPC. Yeah, that's basically what our stack looks like. And it works really well for native bindings for iOS, Android, Node.js. But like for browser, doesn't work too well. All right, yeah. So like, what about for web, right? Because SQLite depends on C, so you can't just use that on the web. And the library used for gRPC isn't really supported in WebAssembly or like on the web at all either. And so like, we kind of have a problem because the whole idea behind using libxmtp is to have reusable code between all these SDKs. And so that, if we have a bug, we fix it in one place instead of like 7 different places. And the browser poses a huge problem because, how are you supposed to kind of maintain those properties without a lot of disruption? Yeah, so like, what's the best way that we can do to start to solve this, right? Like, I think gRPC a little bit easier because we can just replace that with HTTP. gRPC, if people aren't familiar, is the protobuf Google RPC standard, and on the back end you can define it to work with HTTP instead of over protobuf, and so you just replace that. HTTP works in WASM, works on the web. It's great. Like SQLite, it's kind of more mysterious. And I talked a little bit, like I mentioned WASM, I guess. There like WASM is a thing that people have been talking about and using. And so I think that we started exploring how to use WASM for SQLite, and try to get like the browser part of our stack into existence. And so yeah, so I guess we started exploring WebAssembly. So like, what is WebAssembly? Before I delve into like the solution, I'll talk about WebAssembly a little bit. Yeah, like what is basically WebAssembly is just a compilation target. In and of itself, it's not super interesting. It's just like you can compile your language to WebAssembly. So if you have like C, you can say, instead of targeting x86 or like ARM, if you're on Mac, you target WebAssembly and it spits out some code that is a standard specification that says this has to be compiled in a certain way. And so browsers can sort of understand that. And I think the interesting part of WebAssembly, the more interesting part is really the runtime. It's usually always paired with the runtime. And I think when people think about WebAssembly, they really think about the runtime because WebAssembly is pretty useless without a runtime. There's a lot of runtimes out there for WebAssembly. I think so. This meme I will explain. Basically, WebAssembly doesn't know anything about its host environment. So everything about the host environment that WebAssembly gets is from its runtime. So runtime decides everything that WebAssembly knows. So like it doesn't know anything. Like the browser will say, this is what console.log is, and now you can print stuff, or this is how you write a file, or anything that WebAssembly needs, it has to sort of call out into the browser. The browser has to give it to WebAssembly. And so it doesn't really know anything about its environment. So whenever you code WebAssembly, you kind of have to assume that it doesn't know anything. Anything that you need, you have to take from the outside. Yeah. So every browser will have like a host environment that runs WebAssembly and inject everything that WebAssembly, I call it like a blob when the compiled WebAssembly result, that WebAssembly blob needs to interact. And I think a lot of browsers pretty much support all the APIs that WebAssembly really needs to run. But there's 2 really important APIs for SQLite, which are OPFS and IndexedDB. It really makes SQLite possible in the browser, right? So like without these APIs, probably wouldn't be possible because it wouldn't be fast enough. But OPFS is a newer one, I think, and it's all browsers support it. And it's basically just like a storage endpoint for the file system. So it kind of mimics like the OS file system, but like in a browser. So you can read and write files. The files are like sandboxed in the browser. So it's not like you can't just search your file system for this file that OPFS wrote. It's within the browser defined, however the browser wants to implement the spec, it's there. You can import and export it, but you can't just like, search your home folder for some file that OPFS wrote. IndexedDB is another API. It's more lower level. It's kind of like a DB, like a key value store that is transactional. And so these are sort of can read write really fast and all that kind of stuff, but it's different in OPFS that it's explicitly like a database rather than just reading and writing files. Yeah, so what about like SQLite and WebAssembly? Well, like, we're going on this WebAssembly kind of journey looking for how we're going to get SQLite, and it turns out there's a lot of different ways SQLite has been turned into WebAssembly. You have the official WebAssembly build by the SQLite team, which can produce a WebAssembly artifact with either Emscripten or CLang compiler. And then you have Roy's build, which is explicitly like a synchronous and asynchronous build. And he builds on that with a bunch of different kinds of virtual file system that he injects into the SQLite stuff. It's all made possible by like an interface that SQLite defined. That's like the function to use it, which is SQLite 3 register VFS that actually SQLite lets you define how you should read and write files, right? Like at the end of the day, we're talking about just reading and writing files in very fancy ways that SQLite allows you to do. So like that's kind of like the core of that, right? For that allows like, you to use IndexedDB to inject into that or inject OPFS into that or any other kind of system that you want. Yeah. Cool. I'm going to summarize WebAssembly so far. So yeah, maybe I'm talking too fast, but I just talked about everything WebAssembly. So I'm just trying to set a basis for what I'm going to talk about next. Basically, just to summarize, WebAssembly is a compilation target that can be targeted by LLVM. Everything it knows is injected from the outside. Pretty much any language can target it. You got any language that uses LLVM, like can use WebAssembly. CLang supports WebAssembly. Lots of different compilers support WebAssembly. There's a growing like tooling community. There's a lot of runtimes. I think WASM time is a very popular one, and there's a lot of activity in runtimes because it's very interesting to run WebAssembly, not even on the web, but just, have kind of like the JVM just throw around a WASM blob that you can run wherever you want. You can run it within like a Go environment or wherever, and still have the benefits of a sandboxed environment with all that kind of thing. Yeah, and so it's kind of like the JVM where you have like this generic bytecode and the runtime where like the OS details are abstracted away and you can just throw it around and run it wherever you want. Yeah, I guess we can stop for questions if anyone has questions. Otherwise, I'll just keep going into like the Diesel implementation stuff. Cool. No questions. All right. Yeah, so I guess the question now is like how we have a SQLite, like some kind of notion of a WebAssembly build for SQLite. And we have like this, we could sort of know that we want to use WebAssembly. We can compile, we know that our library will be compilable to WebAssembly. We can use Rust native dependencies. Like how do we like fit in SQLite WASM into our stack right now, right? So like this is a separate, one thing to note is like a separate WASM module. So it's not just like, you import the SQLite WASM into the Rust library and just use it. It's a separate module. So that means it's its own sandboxed environment as opposed to like our sandbox environment. And so like one thing that's interesting is that we use this library called Diesel, which, is the kind of entry point for SQLite for us. It's a library that abstracts away just raw SQL into something called an ORM, which is like a kind of Rust way to use databases, and it supports Postgres like SQLite and MySQL. And so I started looking into that and found out that they actually have a lot of so I guess before I get into that, it's like this problem of how do we reuse the code that we already have? So we're already pretty happy with how we get data from libxmtp and use it with OpenMLS and all these other different things that we use it with. And like, how do we avoid sort of ripping all that out, defining like all these generic traits to access our data, and then like compiling it to WASM to like, like, how do we just keep it the simplicity where it is and just kind of maybe like punt the complexity of implementing like SQLite WASM somewhere else, right? So we look into Diesel, which abstracts away SQL. And they have a lot of really great traits interface for that abstracts away the raw SQL queries into ORM. And yeah, so we can basically use the Diesel DSL, which we call as a domain-specific language for the like SQL backends. And a SQL backend would be like Postgres or SQLite or MySQL. But like, how do we specifically use Diesel with like the SQLite backend? And we would just have to take the SQLite, SQLite WASM binary, basically, that we have from SQLite WASM and implement the connection interfaces for Diesel. And then when we do that, we'll basically, libxmtp will not know at all like that it's using SQLite WASM. It'll just use the Diesel ORM that it's always been using. But behind the scenes, instead of, SQLite using the operating system, like read-write operations, it'll use the browser injected APIs that the WASM blob gets from the browser runtime. And then we get the same result, just reading and writing a bunch of like a file, database file, or a bunch of files that store all the, messaging and OpenMLS data that we need to store. Yeah, so this is kind of the stack that was decided on. We'll take the SQLite blob, we'll import it into our Rust library with another library called WASM bindgen that allows Rust to sort of bind to like WASM binaries, and then we'll implement the connection traits on it. And I guess the next question is like, does that work? And I think the answer is like, yes, it's working now. We have ORM working with WASM. The next step is just to integrate it with XMTP MLS. And I think this meme is like, make it work, make it good, make it faster. I think we're still at the make it work of integrating it into XMTP MLS and kind of going through that process of, getting XMTP to compile to WASM, using it with SQLite in the browser, and then, testing it out end to end with the SDK. And then at that point, we're like, okay, how do we make it better and make it faster? And yeah. Cool. Anyone have any questions about that before I get into like the problems and other, like, I'll just keep going down the stack sort of.
Yes, I have a quick question, and sorry if it's a dumb question because I'm not a developer, but so the current way the web application works with no MLS, like the one that is in production right now on Converse, for example, loads the messages every time you open a session. I mean, there is nothing that is kept in cache, at least to my understanding. If I like leave and come back to the application, and so is the new configuration that you are using able to actually keep the messages from one session to the other, and even sometimes like every message for a given user in the browser? So yeah, the simple question would be, can it keep in the local storage every message, so that when I open the app and then when I interact with the app, it's actually very fast because it's already stored locally, which is the case in the iOS application, for example?
Yeah, I think if I understand your question right, you're asking, are the messages persisted so you don't have to go to the network each time? Is that correct?
Exactly. Somehow that would be my question. Yes.
Yeah. So these APIs that like the browser defines, OPFS and IndexedDB, they're actually persistent APIs. So once you save something with SQLite with OPFS and you close your browser and you open it again, and you open the same database file that you have, you'll have all the same messages that you had in the previous session. Of course, if you delete your browser and you wipe all the data stored to the browser, you'll have to reload everything. But as long as you don't delete your browser, like OPFS, it'll have it, IndexedDB will have it. And I'll load it from the database rather than going into the network.
Okay. Yeah. Thank you.
Yeah. No problem. Cool.
Another question. Is the goal for the Diesel stack is that just specifically for the web, or would that be kind of like pushed to the rest of the kind of like mobile app SDKs as well?
That's a good question. I think it would be interesting to see like a world where we use WASM in the mobile SDKs too, like with WASM time, like a runtime like that. I think right now we're just focused on sort of filling in the gap in our stack with the browser. So all the work I've been doing with SQLite WASM has been like very browser focused. If you try to use it like in a mobile stack, it probably wouldn't work at all. Yeah.
Got it. Thanks.
Nice. All right, let's go on. Yeah, does it work? Difficulties. Yeah, so I think some difficulties. When I first started working on this, I sort of started with Roy's build of SQLite, which was it's like strictly asynchronous build. And I thought that was really cool because, you know, everything in the browser, it's got to be async, you can't block. It didn't really work out. I think async, there's no async drop in Rust. There's no guaranteed drop order. So you kind of miss some optimizations you can do with statements where like you make a statement and then you cache it and then you like reset it when it drops. It's not as difficult. Reverted to like a sync API, everything works great now. I also know async closure. I think there's some dependency on like JS async closures, and it was like difficult to sort of cross the barrier there. Yeah, there's no real threading, so it's important for at least our XMTP, like our MLS library, not to block at all, because everything will halt. Even in a web worker, you can't block. It'll just like return an error. Yeah. Let's see. Yeah. Yeah. So the interesting about, I guess I should mention here about the SQLite build is that it's still async. It's just sort of like fake async because it actually spawns a web worker in the background, and all your file IO happens in this web worker. And from the thread you're working in, it looks synchronous, but in reality, it's actually like being processed by this like worker somewhere else that's just like buffering your requests and stuff. But like Roy's build like explicitly makes things async, and so there's kind of like a performance optimization there. I think that's interesting. Yeah, so future work, like we have like the SQLite build working with Diesel. We have ORM synchronously. Obviously, we have to integrate that with our current XMTP stack. Make sure our current library can compile to WASM. And I think the next step really is how can we make it like the library really good, right? Like so right now, we're sort of marshaling data between our like Diesel WASM host and the SQLite WASM host. They're completely separate modules. And so WASM as like a sandbox technology, you have to sort of you always copy the memory back and forth, which like isn't ideal. And so like I actually have like a diagram here is we're copying to SQLite and back. Like if we can sort of get SQLite to share the memory with our WASM host, that would speed things up a lot. And get them sort of playing in the same sandbox. So instead of throwing the shovel like to the different sandbox and like yelling and shouting, you can just share the same shovel like, you know, a foot away or something. Yeah, and there's a bunch of different work that's been around this. A lot of it is very recent. Like this PR was just merged into Rust main for a WASM C ABI, which would allow you to actually link the SQLite C library right into our Rust library and compile it all into WASM at once. And then that way they would all share the same WASM memory space. And you would no longer have this kind of back and forth where you have to copy from one WASM memory to your like our WASM memory and that kind of thing. Also like a VFS implementation. So like right now, a VFS is the virtual file system. It tells SQLite how to, you know, read and write files, like file log, deal with file locks and all this kind of thing. And right now, all the VFSs for our implementation of SQLite are defined in JavaScript. And Roy did a lot of really good work on defining VFSs in JavaScript for SQLite. There's like 7 or 8 different VFSs there, and they all like have different trade-offs. We're using one that uses like a synchronous version of OPFS. But it would be nice to also like have a Rust VFS that binds to the OPFS API with WASM bind gen and is included right in the library. So that also sort of is all sharing the same memory. And yeah, so that's like a pretty big chunk of future work that would probably make things a lot more optimized. In addition, there's definitely some concerns over like browser concurrency. How are we going to handle multiple tabs? I think as well, Roy like it's part of the trade-offs of VFSs is how this is handled. And so, yeah, like if you open a database in one tab and it's accessed in another tab, how is that handled? There's a lot of different ways to do that. Yeah, so there's WASM memory ops here. I guess if you want to know about WASM memory, it's just kind of a view as a unsigned 8-bit integer array that you write and read from. There's different views of it, so you can view it as different sized bytes. But that's basically just copy paste pretty much from one memory to the other. Yeah, and so that's pretty much our complete client stack. Yeah, WASM for the web with SQLite WASM, and then everything should just work if you plug in the SQLite WASM library. Yeah, thanks. Cool.
Wow, fantastic, Andrew. Thank you so much.
Yeah.
Also for the graphics.
Yeah, no
Would you like to take any questions, Andrew? Anyone have any topics they'd like to dive in deeper to what Andrew shared?
Yeah, let me just stop sharing my screen here. I don't know
Yeah.
where. I don't know where the button
Morgan.
on Zoom. Oh, there it is. All right, got it.
Thank you. Yeah, please go ahead, Morgan.
Yeah, since we have kind of a web client, this is like super exciting for us. And I hate asking this of, the developer community, certainly developers on our own team is like, what's the time frame for it? And you had kind of like 4 images there, it's like, it's working, make it better, make it faster, get it working again. When can we expect to kind of like play around with it just in terms of like testing things out, even if it's kind of not the optimal form? And then ultimately, is there kind of like a target date for a release for when you're seeing some of these parts come together?
Yeah, so I think the biggest thing would just be releasing it as a crate so people can just include it in the library and use it, which I think it's pretty close. Like I can pre-release a crate right now for people to play around with. Yeah, so there's no target date, but it's definitely something that can be done like the next couple of weeks because I mean the core, like there's definitely gaps in what like feature between what the normal Diesel SQLite backend can do and the WASM backend can do. But like just like selecting, loading, and like basic queries will definitely like work now. Yeah, and that can definitely be released as a crate for sure.
That's like way faster than I thought you were gonna say. It's great news.
Yeah.
Nice. Well, any other questions about the presentation? And maybe we could, since we have folks who are building for the web here, is there any maybe related feedback or any related questions, beyond what we talked about today that you have on your mind?
I have a question. Andrew, you mentioned some of the remaining work is compiling libxmtp to WASM. I think, yeah. So can you maybe add just some detail about that, about like maybe some of the challenges related to that and how, integrating the SQLite WASM, if there's any nuance, like once we can compile libxmtp to WASM?
Yeah, sure. I think the like Rust has really, really good support for WebAssembly. Like as long as your Rust program is pretty much just Rust and you don't use any system libraries, it's pretty easy to get it to compile to WASM. And so the biggest hurdle there is like we have the SQLite dependency that we have to just put under a feature flag, and we have to just go through all our dependencies. And if anything's depending on a C library, see why we're using that dependency and either replace it or like put it under a feature flag and replace it with something else. And I think right now we're really not using anything other than Ring for some HMAC stuff that can be replaced fairly easily. And then you just, the way the backend would work was you just import it as like a Rust crate, just like how we, import Diesel, and replace, our SQLite connection with a WASM SQLite connection. And then, yeah, should all compile to WASM.
Cool, awesome. Yeah, that was really helpful. Thanks.
Yeah.
All right. Any other comments? Any other questions? All right. Hey, gosh, thanks so much again, Andrew. Masterclass.
Thanks. Thanks for letting me present. Yeah, it's cool.
Oh.
It's cool working on the project, and I'm excited to just like take it even further. I think.
Fantastic. It has been really being on the team, it's been really amazing to watch the process and the problem solving that happened, and it's really inspiring. So thanks for sharing that with us all today. We have a couple of more topics. We have about 10 minutes left, and maybe we could go through the rest of the agenda now. I think Fabri has some exciting developer experience updates to share. Let me go ahead and share my screen, and we can go there. Here we go. Fabri, take it away.
Hey. Yeah, quick update. ETH Online has started over the weekend. Lots of devs have been asking questions in both the ETH Global Discord. There is the XMTP channel inside the ETH Global Discord, and also our own Discord, the XMTP Discord. So if you're building in ETH Online, you should know we are offering up to 10K in bounties. Bounties involving building in the app layer, mini apps, bots, frames, and AI agents using MessageKit, one of our latest SDKs, and also using XMTP, maybe for sending notifications, subscribing, or building inboxes. We are giving bounties for also the best use of XMTP protocol. And if you want to learn more, today we are doing a workshop about building in the app layer, building with bots and frames, and it's 4:30 Pacific time. And in the slides, you're going to find the links of both the workshop and also the prices and the bounties related to ETH Global. Remember, ETH Global goes through a full month. So it just started and it's going to end of September. So yeah, if you have, of course, any questions, please reach out. And that was me. Thank you, Sheikha.
Oh, fantastic. Great. Thank you. Any questions? All right. Great. And now, Naomi, I'm wondering, do you have any updates you'd like to share from engineering?
Yeah, I think, we're still working on group chat mobile, trying to get a stable version out on Converse so we can release test flight for that hopefully soon. What's coming up next is one-to-one backed by MLS. As you just heard, group chat web, that's coming up real soon. We've got smart contract wallet stuff kind of queued up. And also, I guess what I should have added to what we're working on, this morning I saw that the message history example looks ready. So people who are curious about interoperability between apps, we now have a working message history example thanks to the team. So yeah, I think that's it on the engineering side, unless anyone has any questions. Oh yeah, we're going to have an Android and an iOS version. Yeah, hopefully releasing at the same time.
Great. Thanks so very much. Thanks, Naomi. Thanks for the question. And I think lastly, I'll go ahead and share some updates about our XMTP improvement proposals. XIPs are a way to propose improvements to XMTP, and anyone can propose one and anyone can provide feedback. So the XIP for which we have notable updates right now is XIP 43 for consent proofs, moved into last call status. And so if no non-normative changes are requested, it'll become final on September 9th. We will share the deck. So if you'd like to explore that XIP a bit more, you can do so and comment if you have any questions. All right. And I think we have come to the end of the program today. We do have a few more minutes. If anyone has something they'd like to bring up, we can open up the floor. All right.
I've got, I feel like it's like the elephant in the room with the whole like Telegram activity. Have you seen a bunch of new activity on XMTP as a result of everything that's going on in regards to that situation? In like a really, hopefully in a positive way?
Such a great question, Morgan. Anyone on the team have any thoughts they'd like to share on that?
I think everyone in the, crypto community has been asking questions about how do we get off Telegram for a long time, and this is just a kind of forcing function to say maybe this isn't, the best, most sustainable platform for our community, and so I think this has been happening for a while. But yeah, people are obviously, concerned about the platform and its health and stability, and what happens when they're coerced by authorities, given all your group chats are not encrypted on Telegram, and are looking for alternatives. And yeah, I hope they'll come to XMTP.
Any other thoughts from the group?
Yeah, in terms of numbers, I can actually see a weak signal, which is that the current version of the app in production still prompts people to actually talk to me whenever they start to use the app. And I've had a few people reaching out to me yesterday and today about this particular topic, actually, like asking questions about the encryption of XMTP and the seriousness of the protocol. And the truth is, like, it seems that people are interested in it. I cannot say that it's thousands or even millions of people, but my intuition is very similar, which is that it's long term. It's about trust, and even if Telegram is gaining a lot of users from this situation, it highlights so many weak points that they have that in the long run, this seems like a very positive thing for decentralized networks such as XMTP. Not giving like political opinions about whether France should actually put this person in jail. This is not the topic to me. But in terms of how serious a project can be, this is an important point, I think.
Thank you for sharing, Paul. And we have a question from Sean in the chat. Is there a recommended way to create an NFT gated group chat? Would it be through the moderator of that chat or app protocol? Any thoughts?
I can field that one. So there's two ways to create a gated group chat. You can have the group be administered by a bot, and we have a Node.js SDK that you could write that bot, and then it can add and remove people based on whatever criteria you want, including NFT gating. And that's kind of the easiest way to get set up. There's also a fancier flow where you can not have a bot in the conversation for privacy reasons, and do this at the app layer, where maybe the administrator of the group gets pushed a notification, and that tells them, hey, you should check the blockchain, make sure this is correct, and then add the person to the group. And both of those will work. One's easier to get spun up, one has better privacy, but at the end of the day, we leave it up to you to design whatever is the right solution for your users. But the protocol is just administering, these are the people in the group, and it's kind of separate from the blockchain, but we can hook these things together in nice ways.
Cool, thank you. The first way should be perfect, so glad it's easy. Yeah, I'll probably do something with that for this hackathon, Fabry. So I'll talk to you this week about it. or if
that's
group
good.
chat is possible to be used in the app, or in the mobile version before the hackathon ends, it'd be cool to have a project with it.
Yeah, you can also use the React Native example app for groups.
Okay, cool.
Fantastic. Well, it is looks like it's time for us to wrap up now, unless anyone has any burning thoughts they'd like to share. What a fantastic meeting today. I really appreciate everyone's questions, everyone's comments. Really fun to share this space with you today. All right, until next time, take care. Bye-bye.